Good morning, everyone. Can you hear me okay? So before we start, let me give a bit of more context of who I am and where I'm coming from. Even though the introduction was great, and as I mentioned, I know that I'm the only thing standing between you and lunch. So I will try to be condensed and engaging to you. So the name gave it away. I am Portuguese. My hometown is actually 40 kilometers south from where we are today, but I've been based in Finland for the past 10 years. I work at a company called Fortum. You might not know what this name means, especially here in Southern Europe, but Fortum is actually one of the largest European energy companies. We are present on the Nordics and Central Europe, and our mission is simple. We drive the change to a cleaner world. Simple. Of course, in Fortum, I work as head of technology and architecture. So my job is to drive our software engineering strategy, governance, our ways of working, our tooling, and serving as a technical advisor to many of our engineering teams. Now you might be wondering, what does an energy company does when it comes to technology? Well, quite a lot of things. If you think about our mission, which is driving the change to a cleaner world, right now you cannot do it with technology. Technology is present in all the aspects of our company. Our company is a very large group, so you can also see it as a group of companies. And in fact, that is to some extent actually quite true. In one hand, we have different divisions: generation, trading and asset optimization, generation of electricity, nuclear, wind, solar. We also have a division for district heating and recycling and waste, and another one for consumer-specific solutions. So as an enterprise-grade type of solutions is quite extensive and quite challenging. To make it even more challenging, we have an ecosystem of startups that we also drive. So we have startups within this ecosystem that are fully ventured within Fortum. So our group is vast, and our group is incredibly challenging to drive. Now, we're here to talk about DevOps. I want to start with talking about cloud native and DevOps together. Why? Because we actually had, earlier in the morning, we had Manuel and we have Antoine talking a lot about these topics. So they actually touch a lot of the topics that I'm going to touch, but I'm going to give you a different perspective, a behind-the-trenches perspective of a multi-billion company on how this actually looks and what are the challenges that we face. So as we know, cloud native has multiple meanings and DevOps has multiple meanings. When a team starts to use cloud for the first time, they might deploy a virtual instance. They might do a lift and shift migration, right? We have been there, most of us, I hope, or maybe not. If you are lucky enough, you haven't been there. And the challenge is that cloud native? Now, as engineers, we know that it's not cloud native. We know that that's maybe just the first stone, the first stepping stone to larger things. We know that, for driving to engineering excellence, you need to drive towards microservices, containers, serverless, event-driven, to different type of an evolutionary type of architecture that is not just a virtual machine sitting in a public cloud. However, the sad reality to most of you is that your customers, your business stakeholders, they don't give a crap about that. Ask if your mother is the customer of your company, do you really think that she cares that the thing is running in a virtual instance or in a nice Kubernetes cluster? She won't. What she cares is that the service is creating the value that she expects from it. And this is a sad reality that we as engineers need to suffer sometimes, meaning that the concept of cloud native and DevOps is a bit murky. And why is it murky? Antoine was making a point that today, there's a lot of people that still don't know what DevOps is. So we are here to talk about the future of DevOps. What's next, right? And the challenge is that 5 years from now or 10 years from now, we will still be making the same question. There will be people that don't know what DevOps is or that have a definition that changed from ours. And the reason for that is that contrary to technologies like AWS, Microsoft Azure, MySQL, Postgres, Python, Java, that are things that we know what they are, DevOps is more abstract. Cloud native is more abstract. There's no exact way to measure it because it is not the technology, it's how we do something, how we drive technology. It's a cultural thing. And that's why it's so hard to attain. So we will never get, apologies, this is quite large, and I still managed to drop it. So we will still have 10 years from now, maybe raising the same questions. So I want to invite you to go through a journey with me. I want you, for the next 20 minutes, to become the CTOs of this large multi-billion energy group. And no, I will not give any raises. We will all be the CTOs for the next 20 minutes, and I want you to think like a CTO. Meaning that I want you to think not just about the technology, but I want you to think about how you are driving technology and why you are driving that technology strategy. So we need to start in connecting the two realities. One is that why we are doing this to create the business value, to how we are doing it because we as CTOs, we want to drive for the engineering excellence, right? So we first need to think about all the challenges that we need to face. Of course, compliance and regulatory are constraints that we need to face, especially in the energy business. We have nuclear power plants and things like that, so just by definition, that creates some regulations in certain specific business areas. We need to think as a large group that we are facing mergers and acquisitions. We sometimes acquire a company, we sometimes sell part of our business. And that's something that you need to think as CTOs for the technology strategy. Also, the geographic locations. Where are actually your customers in the different business areas? Do you have customers mostly in Europe, or do you are using, for instance, do you have customers or segments of customers in Asia? Because the technologies that you adopt, especially in terms of cloud, will likely need to be a little bit different. Also, any capacity commitments that you might have, for instance, with a certain vendor. Did you already made a plan to purchase data centers for the next 5-10 years? Or any kind of public cloud vendor? You need to think about this existing business relations. So my point here is that we need to think a lot more than just specifics of the technology. And those are the constraints that we need to face. To some extent, I classify my job as making sense of chaos, or bringing some structure to chaos, or how do I move the mountain? Moving a mountain is very hard. It is possible, but it's very hard. As a large organization, we need to think about having flexibility. Flexibility meaning that all our engineering teams, they need to be autonomous. They need to be fully independent and on creating the value end-to-end. Because for many reasons, because A, that's part of the engineering excellence that we want to achieve, but also because of the challenge that we might need to sell or acquire another company. So we need to create a lot of flexibility. As such, to move that mountain as CTOs, and often when we are thinking about how to do engineering excellence, we always think that our company culture is not like that. Management should do something about that. Well, guess what? Now you are management. I made you CTOs. So it's up to you, to us, to drive it. There are 3 things that we do that I think drive us towards that direction. One is that we have open governance and strong operational foundations. This means that we have those operational foundations are specifically about the cloud ops and platform engineering, and also data integrations. Not in the sense that we have a platform engineering team that all the applications team need to use. That's not about it. Quite the opposite. Very lightweight, meaning that the teams actually are ones driving and doing the change, but we provide some structure to things and we enable them. We are not the bottleneck. Now, to make it more challenging, we have different technologies and different, even on the cloud level. So we have some teams that are using Azure, some teams that are using AWS, we have some teams that are using Kubernetes, some teams are using completely serverless event-driven architecture. We need to create that flexibility. That is part of our DNA, because we cannot standardize things when we have different business divisions, when they have different business cases. Each of the teams needs to be autonomous, I mentioned that. But what does it mean? It means that there needs to be a multi-competence team, meaning that the team needs to have not just software developers, not just a DevOps engineer, not just a quality engineer, also designers, as an example. It is a full-fledged team with different components brought together. It means that the work of DevOps is shared across the team in a way that you could almost say that the DevOps engineer is a coach towards the team, not the person who builds the pipelines per se. We need to enable transparency. What it means is that the team knows what is expected from them, why they are doing what they are working on, and that there's escalation paths to different parts of the company when they need support. I will summarize maybe our biggest change in driving this is that treating operations as a value center, not a cost center, meaning that quite often organizations are driven to think about application development or digital development in the sense of we only need to do the code. The code is the part that matters, the application code. We know that that's not a reality. Application code can be very beautiful, but if it doesn't scale, if your website is not up, if your service is returning HTTP 500, no one will see that beautiful code. Operation is to be part of the value creation center. And that's incredibly important to start driving things. However, there's the famous saying, if you add digital on top of something that is broken, you have a digital broken thing. And that is very true. We cannot, when we look at different engineering teams, it's not one size fits all. We have engineering teams at different maturity levels. We cannot say that as an organization we are very mature. We have parts of it that are more mature than the others. And when we think about technology excellence, we think using modern tools. Come on, you all have your preferred tools. And you think, when you start a project, blank slate, you think, I'm going to use this nice tool. But the thing is that if your team culture is broken, having a nice tool doesn't really work. I mean, think, for instance, in construction. If I'm giving really nice construction tools to each of you, would you know how to use them? Not really. If I give you a hammer, you might know how to use it. I hope you know how to use a hammer. But my point is that tools are just tools. They need to fit, they need to be purpose fit. It doesn't matter if you are running a nice, shiny tool if you don't know why you are running that nice, shiny tool, if you're just making a website. I once, not at Fortum, but as a consultant, I engaged with a customer. And the customer has spent 1 year making beautiful Kubernetes foundations as a platform team. For that whole year, they were running one static website on that. So my point is that it needs to be fit for purpose, and that is super important. Now, how we enable that change is important, because, as I mentioned, we need to enable teams. What does that mean? It means that teams have a huge cognitive overload today. It's the different tools, the different processes. It's crazy. Being a software engineer today, regardless of your area of specialization, is rewarding, but it is mentally quite a lot of effort. One of the things that we do to enable teams is security threat modeling. Now, security threat modeling is not something new. It exists for the past 20, 30 years. And any information security professional can tell you that, yeah, I've been doing that for a long time. But it is not very common for software engineering teams. And what we started to do is to run these workshops. Doing a security threat modeling workshop takes roughly 3-4 hours, and it's something that we do periodically. We try to do it every year with each of the teams. Now, you can always hire. We've been doing this actually for a long time, but one key thing's changed in the past 1-2 years is that we start outsourcing that. We start inviting security specialists to do that. Rather, we start to have someone from the teams, someone from this centralized enablement teams, to run that. And one funny thing started to happen. When we started creating to do that internally, all of a sudden, people realized that this is actually not that hard. If, for instance, if you're a software engineer and you have some passion for cybersecurity, you might be wanting to start doing this. Not necessarily with your team, but with the team next door. And that's exactly what started to happen. So we started to have like a virtual pool of facilitators that, a person from team A was going to facilitate this on team B, and someone from team B was doing it on A. And we started to build that type of community that shared this. I mentioned security because security is incredibly important to us, obviously because we are an energy company and there's a lot of constraints. Now, what we get from this threat modeling is that we get a list of risks. We get, what are the challenges that we might face from a security perspective, And that helps the team, when they get there by themselves, to actually raise the bar into their engineering excellence when it comes to security. Another assessment that we do is the well-architected review. So if you are using AWS or Microsoft Azure or Google Cloud, actually it doesn't matter which public cloud you use, quite likely chances are that they have a well-architected framework. It is nothing new, it's been there for years. A well-architected framework is essentially a collection of best practices. It is under 5 to 6 pillars. It is what teams should start doing or start considering. Now, you have operational excellence, security, reliability, cost management, performance, and sustainability. Those areas give you a very holistic picture for an engineering team on how well they are performing in different areas. It is an assessment that we also do similar to the threat modeling, meaning that we have a group of facilitators that are facilitating this with the teams once a year. And what we get out of it is that, we started to get quite good risk scores. We started to understand with the teams, what are the areas that they were maybe having more challenges. For instance, as an example, you get automatically this type of nice assessment with this nice scorecard, if you will, that gives you, from the questions that the team answer, what were the high and medium risks. Now, you can actually see in this particular scorecard that there are higher risks across all the areas. But you see perhaps that reliability and security have a bit more than the others. So perhaps that's something that you will start tackling first with the team and start helping them more looking at those areas. And of course, with the assessment itself, you get some pointers on what actually those things are. You get the key findings and recommendations. It gives the team an outside perspective because someone will facilitate, but it's not an audit. I'm not, as a facilitator, I'm not there to judge. I'm rather there to facilitate the discussion. It's up to the team to actually come to the conclusions if they are doing certain things or not. But it gives the team also a chance to communicate with us, CTOs, that we are here in this room. Now, what does that mean? It means that you start to see, when you start running this with multiple engineering teams across different business segments, you start to see some patterns. You start to connect some dots. You start to see some things that maybe are there, and they are maybe you, management, should do something about it. This was actually what came to us. That was a conclusion we started to do. When you start doing 3 to 4 of this, you start to see some of these challenges. And one of the things, among others, that we saw is that, the company had quite a lot of guidelines, policies available, enablement teams. We have an amazing cybersecurity team. We have an amazing SOC. A lot of engineers don't even know that we had it. And you start to see a lot of these things that, we are having challenge. We don't know how to do incident management. We have this challenge as a team. Yeah, but we have amazing people that can help you with that. Why haven't you mentioned it? Maybe it didn't occur. Maybe they were too busy. So we started to see this pattern, and something that we are doing, I say we are doing because we are putting still a lot of focus on it, is we start to curate a handbook, a digital development handbook. Not taking credit on this. This was something actually inspired by a company called SOK. SOK is one of the major retail companies in Finland, is the equivalent of Continent or Pingo here in Portugal. And they have a really good engineering culture. And they open source these development guidelines. What are the guidelines? Essentially, we're looking at 1.5 page long on must-haves and should-haves. And now you might be thinking, well, I'm an engineer, I'm building things, move fast and break things, right? Now, the challenge is that move fast and break things is not something that you want to mix in a discussion with your nuclear IT team for different reasons. Although, of course, you don't need to treat all the requirements that you have as a company in the similar grade as nuclear. And that was also the challenge. How do you understand as an engineering team what are really the must-haves that I need to understand and do as a team, and what are the should-haves, and what are the nice things to have, what are the recommended things. So by curating this, we build a map. We build a map to the teams to actually find where can actually they find the guidelines about a specific thing. For instance, we don't say you need to use this particular technology to do, let's say, encryption at rest. We say you must have encryption at rest. If they want to understand why that is important, we point them to a specific guideline that tells them why that is important. And by making this collection of different statements across different areas, it's not just, you are seeing here a small example about architecture and security, but there's others. There's quality engineering. There's on data management, you name it. Across all the areas that you expect as an engineer, we are making the map to point this to people. It also makes it easier for us to say, as an engineering team, this is your 10 commandments. That's the only thing you need to understand. If someone said it's not on the policies, go and check there. If it's there, that's what you need to care. You don't need to read 80 pages long. You need to understand what is expected from you as a team. Of course, they are not written in stone as the normal 10 commandments. This is something that evolves. And the point of making open governance is that we are actually getting from the teams continuously what are the things that are missing, what are the things that needs to be changed. We're making this in a very transparent and open manner so that we actually may have policies and have content that actually matters to the business and to the teams. Now, essentially with this, we are connecting different dots. We are connecting the guidelines that are spread across the company, procurement, legal, privacy, data management, you name it, that explain a lot why you should do something, why you should have those things, with what is expected from the team. As I mentioned, we are creating a map. Moreover, we can connect that with also the how, the assessments that I was telling about, security threat modeling, well-architected review. When the teams ask in their assessments, hey, we need help in finding what is expected from us in terms of privacy, you can point to the handbook, which makes it easier for them to actually understand what is actually the must-haves and should-haves. In addition to that, and that connects a bit to the platform engineering part, we have a builder's library, meaning that we have a collection of examples, reference implementations, some small snippets that the teams can use or not to actually build the things. That if they want to understand, for instance, how to enable, let's say, container scanning in their CI/CD pipeline, we have small examples on how can they do that with the tools that we have. That allows a lot of flexibility to the teams, allows them not to be bound by a specific things that they need to use rather than they want to use. Now, of course, we need to make sense of that chaos. We need to give a way to point to all of these things. And we are connecting those dots in practice with a tool called Backstage. I know I didn't want to talk about tools, but I need to talk about this one. That's the only tool I'm going to talk about. Backstage.io is an open source project. It was created and open source by Spotify. It has been seeing massive adoption, and is essentially just is actually quite a small tool, but quite flexible and extendable. So we are using that, or we started to use that last year to build a technology radar that just points to the teams, what are the technologies within the company that are recommended for them to adopt, what are technologies that we are trying, what are things that perhaps they should assess or hold or not refrain to use. Essentially, by making this list, it just tells the team what are the golden paths, what are the things that if you are starting a new project, what are the technologies that are being used at Fortum where you will find quite a lot of support. It also allows them to experiment. So if they are thinking about using, let's say, a specific tool like AWS CDK, they will see that, okay, there's some team already trying that. So they can actually ask for recommendations or to just spar ideas. So we have that tech radar, and then we started to build it. The handbook, it's also in the same portal. Backstage is essentially our technology internal portal, if you will. It also helps to connect with this builder's library and templates. It makes it easier for people to find the information that is spread. It's also a way that we have for the teams to start publishing, who they are, because we have, as mentioned, different startups, different products and services. It's quite a chaos. We have multiple engineers, multiple engineering teams. So it is a way to make a list of what are the projects that we are working on, who is working on them, and also for the teams to have the chance to publish their, what are their DORA metrics, or what are their SLAs, SLOs, RPAs, RTOs, all of those metrics, they can make it visible there to the others if they wish so. So that helps us a lot. What I want to leave today for you is only this. That's the only thing that I want you to remember, is that it is not just about the technologies. It's not just about the process that you have in place. It's all about the culture. Unfortunately, as CTOs, you cannot buy culture. You need to build that culture, to build that technology excellence culture. You need to do quite a lot of things. It's not just about the technology that you use, not just about the hiring and incentives that you use, not just about, it's everything combined. And that's part of the challenge that we have as CTOs, as management, is to foster that type of culture. But as we know, culture is not something that you build just as a CTO or just as management. Each and every one of us as engineers is responsible for that. So my takeaway is focus a lot on the human side of things and fostering that culture that you want to see. Don't just wait for management or anyone else to do it for you. It's in your hands to build that. And with that, I would like to thank you for the talk.